Okay, we are going to prove case one of the inscribed angle theorem. The inscribed angle theorem references a circle. We talked about this theorem earlier in the year. Here we've got the center of our circle. We're going to call that point O. A central angle goes through the center. I'm going to put one of those here in red. I'll just draw it as a line. And remember that my central angle, MOT, is equal to my arc measure. Okay? Angle MOT equals that measure, so little m angle MOT, is equal to the measure of my arc, little m capital MT. The arc goes from M to T. Okay, so if this angle here, pretend it's 60 degrees, this arc is 60 degrees. Now keep in mind, any angle that goes through the same arc, this is called an inscribed angle. So we've got the central angle at the center, MOT. Central angle. We've got the inscribed angle, the purple one at the side. We're going to call it P. Measure of angle MP, oops, MPT, I got ahead of myself there, is equal to half of the central angle, or the arc measure, since they're the same, which is half the central angle. And if that one's 60, the MPT would be 30. There are three different possibilities for this central angle, or this inscribed angle. We're going to do with case one, where one of the sides goes through the center. Okay, this is what I'm going to prove here in a second. And I'm going to call that one case one. Case two and three are similar. I'm going to let you try those on your own before I tell you how to do them. Okay. So again, O, case two looks like what this one is. This is case two up here. This one here is case one. That's what I'll prove. Case three, here, we're all on one side of the circle. And the proofs are similar, but not exactly the same. Okay, case two is the purple one, not the central angle. So I'm going to erase the central angle right now. Wish the eraser actually worked the first time I used it and only erased what I wanted it to. So that's case two. Nope, I forgot to write 3 on the case 3 one. No. So I'm going to start with the proof. So I'll start with my circle because I'm going to need to label things on my diagram. I've got over here M and T, and right here P. Okay. So my 2-column proof. This is my favorite type. Got my statements on my left here. You should know this by now. I've got my reasons on my right. So I've got angle MPT is inscribed. That means it's touching the outside edge. My drawing's not perfect. It's a little hard to do on the computer. In circle O. I call it circle O because O is the center point of the circle. Measure of angle MPT, we're going to call X. And point O lies on the diameter of PM. All of this information is given to me by the diagram. It's also given to me by the proof here. Shown on page 145. What we're going to do then is connect TO. So this is X. They told me that. Connect OT, O, and T to form radius OT. So that is a radius of the circle. It goes from the side to the center. And that is done with, justified with construction. You can always construct. Because OT is a radius and OP is a radius, OT is congruent to OP. This is the definition of a circle because they're both radiuses. Or plural for radius is radii. Not bath, both. That is the correct spelling for radii. Okay. This means I have an isosceles triangle, which means this angle over here is also X, OTP. And again, OTP, I go from O, the vertex is at T, the middle point, P. That's the isosceles triangle base angle theorem. The angle out here, MOT, is the exterior angle of triangle TOP. The exterior angle theorem says that the remote interior angles, angle OTP and angle OPT, which are both X, is going to be equal to the sum of those two. So measure of MOT equals X plus X, which is 2X. So I've labeled that on my diagram. That is the exterior angle theorem. Or I should probably call it the triangle exterior angle theorem. Oops. Now I also know that that arc wasn't supposed to erase that much. It always erases too much. So the arc MT is equal to the central angle as well. I'm going to call that the central angle theorem. Might just be the definition of an arc. So notice that 2x is twice x, right? So I'm trying to prove that this angle MPT is half MOT. So if that's 2x and it's x, 1/2 of 2x equals x. Let's go back. Let's rewrite that. Since that's how I want to say this. 1/2 of 2x is equal to x. One half measure of arc MT equals measure of angle MPT or OPT. Either one. They're the same thing. And this is by substitution. And that is the statement for the inscribed angle theorem. So I have proven case 1 of the inscribed angle theorem. I've proven case 1. I'm not really done with the proof because I haven't proven cases 2 and 3. I'm going to let you do that. I want you to try working through it. I will help you in small groups at your tables.